right, we're going to do exponential decay. This is the second section. Since we did a whole bunch of experimentation with exponential growth, this is going to go a little faster, okay? All right, so I've got two graphs right there. You don't have to graph them on your calculator this time. I've got 3 times 2 to the x. You can see it right there. And I've got 3 times 1/2 to the x. 1 is going up over time, if we call this time. Going up as we go across. This one is not going up. It is going down. What is the same of those two graphs?
The asymptote.
The asymptote's the same.
Keep on doing the asphalt. No.
And it's positive. They're both above the x-axis. You're right. Mm-hmm. They're both up. They're both on the positive side up there.
They both cross the y-axis
at 3. So their y-intercepts are both the same. Why do you think their y-intercepts are the same? Based on their equation here. What?
Both have 3.
They both have 3 in front. So
and their rate of growth/decay is the same.
Yes. So this is going up as fast as this is going down. Okay. Yes. All right. So this one is growth. This one is decay. Remember, realizing that decay is still above the y-axis, above the x-axis, excuse me. It's still up there. It's not down here. Okay, we're losing money in a sense, but it's not going negative. All right. What could we do if we didn't have a graph here? What if we didn't have that at all down there? How would we be able to know it's decay by its equation?
Fraction.
The fraction. All right, we had an a value here and a b value and an x, right? So if this value is a fraction, it is going to be decay. Okay. All right.
Whoa. Okay.
Let's look at some. Growth or decay? Is this growth or decay?
Decay.
I heard decay.
Decay.
I heard decay. I'm going to tell you, it's growth. Why?
Uh-oh.
3/2. What's the decimal value for that?
1.5.
Okay, so when we talked about, let's go back to this other one back over here. When we had these two equations, instead of saying fraction, what should we have said instead?
Decimal.
What's the value of
Less than 1?
Less than 1. There we go. This value is less than 1, and this is greater than 1. Okay? All right, so this one that I have here is growth because this value is greater than 1. Because the 3/2 is greater than 1. You might want to write that down somewhere, but you don't have to. Totally optional. And that one, is that growth or decay? This one is decay because of the half is less than 1. On the growth equation, what's the y-intercept? 2. 2, because of the 2 right there. And on the decay equation, which one's your y-intercept?
3.
3. All right. This is what we learned. We learned that it's growth. Your a value is going to be greater than 0. It's not going to be negative, just like before. If it's negative, it's going to flip it upside down. That's not going to be decay. And exponential growth is where your b value is greater than 1, and it's exponential decay if your b value is between 0 and 1. It's got to be less than 1, but it was not going to ever be negative. Okay, so it's going to be between 0 and 1. What does a on the graph determine?
Y-axis?
Your y, yes, where it crosses the y-axis. Very good. All right. I'm going to suggest that we can do this when we're going to graph it. This is not going to be very difficult. We're going to find the y-intercept. I'm going to suggest that you actually do a -1 to find your next values. If you remember when we were doing, I suggested that we used 0 and 1 when we were doing growth. I'm suggesting that we use 0 and -1 to do decay. Let's do some. Let's do this one first so I can show you why, okay? My y-intercept, this is number 1, by the way. My y-intercept is 3. Which one of these is going to be it?
C.
It's only going to be C.
Its only possibility is C. Now, I want you to realize that when we were doing this before, I told you that the next one over is to multiply these two together, but they're going to be a fraction now. That's going to be harder. So I'm going to suggest...
I just looked for where they crossed the -1 line.
Yes, it crosses the -1 line,
At
is the
6.
reciprocal of this one. If I put 1/2 to the -1, that's the reciprocal. What's the reciprocal of half?
2.
2. And 2
So
times 3
2 is 6.
is 6, so it crosses at the 6. That's why I'm suggesting you do the -1, because it's the reciprocal of this one to find your next value. Like we were doing before, we just
But when
multiplied
I
those two
can
numbers
see them,
together.
though, I can just look for where it crosses the -1.
Yeah. And it's a 6, but to find the 6 is because it's the reciprocal of that one.
Yes.
Okay, let's do another one. Number 2. Where's the y-intercept on number 2?
-2.
Negative 2?
Positive 2.
Positive 2. Okay, positive 2. Is there only one possibility for that?
C.
No, there's
No, there's
C
2.
and D. And she thinks it's C. Why does she think it's C? The -1 crosses at 6. Which one of those is going
3
to...
times 2.
Yes, it's going to be the reciprocal of that one's going to be 3 times 2 is 6, so it's going to be C. Heidi was right. We can graph these by finding the y-intercept and one more point. And sometimes the -1 is the best one. So let's do number 5. What's the y-intercept?
5. Oh,
3.
3? All right, for that one, are you wanting to do...
sorry.
You want to plug... What number do you want to plug in next?
-1.
I want to do a -1 also. If I plug a -1 in, that's going to make the reciprocal of that half be 2. And then I'll have 6. Here we go. And the asymptote...
Well, we had that over
we did.
in 1.
We did. The asymptote's right there. We know it's decay because we have a half there. So we know it's going down. Going to get close to that x-axis. So that means it's going to start up here and get really, really close to the x-axis. Arrows on that. All right, we learned about exponential decay. Learned how to graph it. All right, goodbye.